Okay, next part, force of interest. So we will go through what is force of interest. We will compute accumulated value and present value using force of interest, and then we will compare constant versus varying force of interest. Okay, first, why do we need force of interest? Consider these 4 funds. We have 4 lines here, 1, 2, 3, 4, and all 4 of these funds, they start at the same point and end at the same point. So within a year it earns in total the same amount of interest. The projection between over 1 year they earn the same amount of interest. However, the actual experience within the year in each moment. Okay, let's look at these 4 funds. There is 4 lines here representing 4 different funds. So this is their AVF, accumulated value function over time. So this is the accumulation function, right? So if you see, for all 4 funds, they start and end at the same point between time 0 to time 1. So we can say their effective rate of interest, I, is the same for their first year. However, we cannot ignore, we can see clearly that their experience within the year differ very greatly. So by using force of interest, we can really differentiate at each moment in time the actual force of interest or the actual growth rate at each point in time. So force of interest is the growth rate at any moment in time. Okay, so we have been splitting our annual I into a smaller sub-period, right? So we got a fractional effective interest rate. So that actually works if our interest rate doesn't change very so often. But if our interest rate change momently, then using J or using fractional I is not going to be very practical. So that's why it's more practical to use force of interest delta. Okay, what is force of interest? Let's try to understand from this illustration. We have 2 funds, fund 1 and fund 2. They both start with 1 ringgit, $1, and then they grow differently. They have different accumulation function, AT. So if you look at this, which one would you invest in? Not from time 0. If you are talking about invest in starting from time 0, then obviously we will choose fund 2. But I want to ask you, which fund will you invest in specifically at time T, at this moment T? And the other clue would be the slope of these 2 funds is the same at this specific moment. So which one will you invest in? So the answer would be actually fund number 2 have a better force of interest. Why is that? Okay, same slope. What does the same slope means? Same slope means that they are earning the same amount of interest at that specific moment in time. So for example if this one is earning 10 cents, this one is also earning 10 cents. However, this one is earning 10 cents with the starting investment of how much? Maybe this one is 2 ringgit, this one is 4 ringgit. So this one is earning 10 cents with 2 ringgit, and this one is also earning 10 cents but with 4 ringgit. So of course, number 1 is more attractive. So to compute growth rate, there are 2 things that we need to consider. 1, how fast the interest that is earned at that specific point in time, and also the size of the fund at that moment. So This is called the force of interest or the rate of growth. So again, I reiterate, force of interest delta at time t is equals to the speed of growth, which is the slope of the accumulation function, the speed of growth, divided by the initial fund at time t. This equation will also can be built with the amount function. So with the amount function, if you remember, the amount function is simply the principal, the investment amount times the accumulation function. Okay, so you can also build the equation for delta using amount function. So it will be the speed of change of the amount divided by the investment at the beginning of the at that moment, at the beginning of that moment, or basically at that moment. Okay, so for example, determine the force of interest at time 0.5 at that specific moment in time, given that this is the amount function. So how do they do it? First, the speed of change of the amount function. So we just differentiate this with respect to t. So how do you differentiate with respect to t? You get 16t plus 2 divided by the amount function itself. So it's 8t squared plus 2t plus 100. And yeah, you are going to evaluate it at time t equals to 0.5. So you will get 10 over 103. Then you will get 0.097. Okay. So here I want to highlight that the force of interest, or your delta, is actually a form of a nominal rate of interest. Okay, hope you remember, nominal rate of interest is I upper m. And the force of interest is actually nominal rate of interest compounded momently. So momently means our sub period is really small. So how many sub period you have? Our sub period approaches infinity. Our m approaches infinity. So this is the formula for I upper m, right? Okay, and then so if we are finding what is the I upper m if the m reaches infinity, using L'Hopital rules, you will get ln 1 plus I. So as m approach infinity, the nominal rate of interest, or I upper infinity, becomes delta, and it becomes ln 1 plus I. Okay, so with L'Hopital rule, we found that I approach infinity will equals to ln 1 plus I. Another fact that we know is, okay, if you remember, if we were to draw the accumulation function of 1 plus I to the power of t, 1 plus I to the power of t is basically a compound interest situation. So it will look something like this. It's an exponential function. This is t, this one is a to the power of t. Okay, so you can write this function in two forms, e to the power of delta t, or you can write it in the form of 1 plus I to the power of t. So this is the function that we will get. It is an exponential function that you will get if our I or our delta is constant. So this function, you can write it in two ways, this or this, right? Okay, knowing this, then if we rearrange this, then you will get delta is actually equals to ln 1 plus I. And we know that the limit of I approaching infinity is also ln 1 plus I. So hence the result of the L'Hopital's rules show that the the force of interest is actually the nominal rate of interest that is compounded monthly. Okay, hope you understand this part. So this is just proving that delta is actually a nominal interest rate that is compounded monthly.